All right, want to continue with the review. This is part 3 of the review. And I told you we want to continue with dividing. This was the last problem that we did. So I want to divide this one right here by using synthetic division. Make sure it's in your view screen. Yeah, okay. All right. Let me just uncover it and remind you of how we do this. All right, first of all, what you do is you take all of these coefficients and put them under here. So this is a 1, negative 2. Yes, you got to put the negative, negative 3, and then 4. You don't have to put the plus, but you do have to put the minuses. And then remember I told you, I said whatever's behind this x, we said it a bunch of different ways, but you take the opposite of it. So this is a plus 2. And I showed you why we do that. Doesn't matter if you remember why, but I did show it to you. All right, so what we do is we start out and we bring this first number all the way down. So I bring this number all the way to the bottom. Now, cross multiply. 2 times 1 is 2, and negative 2 plus 2 is 0. Then 2 times 0 is 0. Negative 3 plus 0 is negative 3. And then 2 times negative 3 is negative 6. And 4 minus 6 is negative 2. Now we have to write out our answer. Well, what will our answer start with? Well, you're dividing x3 by x1. You're always going to be dividing by x1 in synthetic division. So your answer, this will be then x2. So this is going to be a 1, x2, then this will be a x1, this is your constant, and that is your remainder. So if I write that out, it would be 1, x2, you don't have to put the 1, plus 0x minus 3, and then remember we always put our remainder back over our divisor. Now when you write this answer out, you can leave out that 0x. And just write it that way, because 0x is the same thing as leaving it off. Okay, let's look at another one, synthetic division. Now, I wanted to work a second one because I wanted to remind you of something. Remember the dividend, what you're dividing into. If there's any missing terms, you have to put zeros in for those gaps. For instance, x3, x2, constant. There's a missing x1. So when you go to set up your synthetic division, 2, 3, so that's x3 and x2, but there's no x1. So you have to put a 0 in for that, and then the minus 8. And take the opposite of this number, which is negative 2 now. Now I'll go through the process. So start out, bring this first number all the way down. Now cross multiply. Negative 2 times 2 is negative 4. And then 3 minus 4 is negative 1. Negative 2 times negative 1 is positive 2. 0 plus 2 is 2. And negative 2 times 2 is negative 4. And negative 8 minus 4 is negative 12. Write out the final answer. Well, you're dividing an x3 by x1. So this answer will again be a x2. So this is going to be 2x2 minus 1x1 plus 2, and then always the remainder over your divisor. Now, if that remainder is positive, you put a plus right there. Okay. Now, let's go to factoring. And this was a big section right here. Let me remind you of a couple of things. And if you've been watching your videos, and not a lot of you have been, and it's really telling on your midterm and final exam grades. But for those of you that's been religiously watching your videos and taking notes, you've been doing really good in the class. But when we covered factoring, it started in 5.5, 5.6, and 5.7. Right at the end of 5.7, I gave you a note, kind of like an outline on factoring. Let me just remind you of what that was. When you go to factor any problem, the first thing you do is see how many terms it has in it. If it has 2 terms, 3 terms, or 4 terms, those are the only options. If it has 2 terms, you do 2 different things after you look for a GCF. So if it's a binomial, you check for a GCF and then 2 other things. So look for a GCF and then ask yourself, is it difference of squares? Or ask yourself, is it sum or difference of cubes? All right, if it's trinomial, you look for a GCF and then you look for 3 things. Is it the easy case? Is it the perfect square trinomial? Or is it that hard case called the Brew method? We'll do examples of those in just a minute. And then if it's 4 terms, you look for a GCF and then grouping. Let me go ahead and tell you, you won't have to worry about grouping on the final. I just want to know if you can factor binomials and trinomials for the final. All right, and GCFs. So let's look at this first example. The instructions here is factor completely. Now let me uncover it and then I'll come over here and go over it with you. So when I look at these 3 terms, 5 goes into every one. A2, A3, A7, so I can take an A2 out. B5, B2, B1, so I can take a B1 out. Remember, it's basically the lowest of all of them, but it's got to be in every one of them. Now, divide. 5 into 10 is 2. A2 into A2 cancels. B1 into B5 leaves B4. Minus. 5 into 15 is 3. A2 into A3 is A1, subtracting exponents. B1 into B2 leaves B. Plus, 5 into 25 is 5. A2 into A7, that should be a A5, not a B. So let me correct that. That's another reason I wanted to go over this with you. This should be A. A5, and then B into B cancels. Okay, let's look at another one. Trinomial. No GCF. This is the easy case. X squared, X and X. Signs are the same, both plus. 2 numbers, if you multiply, you get 28. Add 11. Multiply 28, add 11 is 7 and 4. 7 times 4 is 28. 7 plus 4 is 11. Trinomial, there's no GCF. Easy case because of the 1. Do your 2 sets of parentheses. X squared is X and X. Signs are the same, both negative. So it's X minus. 2 numbers, when you multiply, you get 10, but when you add them, you get 11. 10 and 1. 10 times 1 is 10, 10 plus 1 is 11. Trinomial, no GCF, easy case. X squared, X and X. Signs are different, largest is negative. So you got an X plus and an X minus. But the biggest number is going to be with the negative. That's what that means. Now I need 2 numbers that multiply to give you 18, but if you subtract them, you get 7. 9 and 2. 9 times 2 is 18, but if you subtract 9 and 2, you get 7. But you have to put the 9 with the negative. Biggest number is negative. Now, if you put the minus first, as long as the 9 is first. Okay, next one. X squared minus 8x minus 15. X squared breaks up. X and X. Signs are different. Largest is negative. Now I need 2 numbers that multiply to give you 15, that subtracts to give you 8. There are no 2 factors that subtracts to give you 8. There's 2 factors that add, but not subtracts to give you 8. So this problem is prime. Okay? Now, let's look at this next problem in its entirety. Come over here and make sure you've got everything. Yep. Okay. All right, so here's the original problem. This is all the work. All right, 6x squared plus 11x plus 3. What's the first thing I look for? GCF. Doesn't have one. Next, it doesn't have a GCF. This is not the easy case because of the 6. It's not a perfect square trinomial because these aren't perfect squares. So this one is won by the Brew method. All right, so how do we do the Brew method? Remember what you do is don't fill this out yet. You have to come to the side. You bring this 6 and you multiply it by 3. So leave the x squared plus 11x alone and take 6 times 3, which is 18. New problem. Now factor this. X squared is x and x. Signs are the same, both plus. I need two numbers. When you multiply, you get 18, but when you add, you get 11. That's 9 and 2. Now, this is where the Brew method comes from. What does the letter B stand for? B stands for bottom. Under the bottom of this 9 and this 2, divide by what you once multiplied by. Remember, we started out with this 6 and multiplied it. Now we're dividing by it. So that's what the B stands for. R stands for reduce. 9 over 6, 3 goes into both of these, so it reduces to 3 over 2. 2 over 6, 2 goes into both of those, so it reduces to 1 over 3. Not 3, 1 over 3. Then the last letter is U, stands for up. So if you still have a fraction, bring this number up. If you still have a fraction, bring this number up. And these are two binomials that multiplies together to give you this. Now remember, the good thing about factoring is you can check any answer simply by multiplying it out, and it should take you right back to where you started. Okay? All right, this next one is just another one just like it. It's just another Brew problem. There's no GCF, that's out. This is not the easy case, and this is not perfect squares. So it's the Brew method. So bring the x squared across plus 10x and do 3 times 8, which is minus 24. X squared breaks up as x times x. Signs are different. Largest is plus. So the bigger number is going to go right here. Now I need two numbers. If you multiply them, you get 24. And subtract them, you get 10. Subtract, you get 10 now. 4 and 6 won't work. 4 and 6 adds to give you 10. So two numbers that multiplies 24, subtract 10, is 12 and 2. And the 12 needs to be with the positive and the 2. Now B. B stands for bottom. The number that you started out multiplying by, you divide by. R is reduce. 12 over 3 reduces to 4. 2 over 3 does not reduce. And then up, bring this number right here up in front. And there's no number here other than 1, which if you bring it up, it stays the same. So these are the two binomials that multiply together to give you that one trinomial. Okay? X squared minus 36, it's a binomial. There's no GCF, but this is the difference of two perfect square, perfect square. So x squared is x at x, 36 is 6 and 6, one's a plus, one's a minus. Same thing here, binomial, no GCF. Is it the difference of two perfect squares? Yes. 2x plus 3, 2x minus 3. Okay? X squared plus 25. Binomial, no GCF, that's out. Is this the difference of two perfect squares? No. Is it the difference or sum of two perfect cubes? No. So this problem is prime. It has to be a minus with perfect squares. Okay? Now this next one is one that you probably have forgotten or rusty on. It's a binomial. There's no GCF. That's out. So I only have two other things to check. Difference of two perfect squares. It's not. Or sum or difference of two perfect cubes. Now, are these two perfect cubes? Can you take something times itself 3 times and get this? Yes. X times X times X. So I'll just put an X under that. Is 27 a perfect cube? Yes. 3 times 3 times 3. So if you'll remember, this is what you put in the A spot, and this is what you put in the B spot. And here is the formula for the difference of two cubes. So you have to memorize this formula in order to work this problem on the test. Now, if this had been a plus, it would still work the same, but the formula would be different. Remember, if this was a plus, this would be a plus, and that would be a minus. But everything else would be the same. So wherever you have an A, put an X. Wherever you have a B, put a 3. So it's X minus 3, X squared, X times 3, which is 3X, and then 3 squared, which is 9. And I told you that sum and difference of cubes only factors one time. Okay, one more on the factoring. On this one, first look for a GCF. It has a GCF. Take out a 2. But remember, the instruction says factor completely. So if this factors again, we need to go on down and do so. This one does factor again. X squared, X and X, signs are the same, both plus, X plus, X plus. Two numbers multiply 12, add 8 would be 2 and 6. So X plus 2, X plus 6. And that's completely factored. Okay, and then the last thing we did in chapter 5, before we started the radical stuff, is we learned how to solve a quadratic equation. Now remember, what makes these I'm about to show you different is they have an equal sign. Now, how do we solve a quadratic equation? So the key is it's got an equal sign here. So you don't do these the way you do in the ones we just did. We're solving. We're finding the answer for X. If you'll remember, there were several steps to this. Step 1, it had to be set equal to 0. So you got to bring that 18 across. Step 2, you then factor the left side. That's a trinomial, the easy case. Signs are different. Largest is negative. Two numbers multiply 18, subtract 7 is 9 and 2. But what you have to do here is you have to go on down and set both of them equal to 0 to find the two answers that work. So in all the ones I did up until now, we were not solving. Up here, we're not solving these. We are here because it's an equation. But it has to be set equal to 0. All right, let's do one more here, and we'll stop the video on this one. So this is what we call a quadratic, because it's x squared, quadratic equation. First, it's got to be set to 0. It is. Now factor it. Now, I'm not going to go through the factoring on this one, because if you will look back about 2 or 3 problems back, this is the very problem we did a while ago on the Brew method. So look up 2 or 3 problems up above this one, and you'll see where we factored it. The difference is, now it's got set equal to 0. So we have to go on down now and set each one of these equal to 0 to find the two solutions. So those are quadratic equations. And we solve those or find the two solutions to those problems. So that concludes this portion. We will pick it back up with the rest of the review on radicals.